Section 1.5, Solving Inequalities. So looking at how do you solve and graph inequalities, and then in tomorrow's video we'll do a little review on how do you write and solve compound inequalities. So just some review concepts in terms of writing and graphing inequalities. The examples they give us compare x with 4. So the first one we have is x is greater than 4. And on the number line, when you graph that, you have an open circle at 4 because it's not inclusive of 4. It's starting at 4.01 or whatever, however small you want to make that number. It does not include the number 4, but anything just a smidgy after 4. So we have an open circle on our graph, and greater than is going to shade to the right-hand side. If you have x is greater than or equal to 4, that is where you're going to shade in that complete dot on the number line. So you would have a solid circle at 4, and then you would have filled in over to that right-hand side. If x is less than 4, less than kind of looks like a little L shape. So if you're thinking about an L shape for less than, that's how you can kind of refer to which one's greater than, which one's less than. Less than looks like an L shape smushed down. So if x is less than 4, again, that's not including 4. It starts at like 3.99999, as close to 4 as we can get, but not quite there. So we have our open circle at 4, and we're shaded off to the left. And x is less than or equal to 4, that's where we shade in to get the including that number 4 before we shade off to that left-hand side. So example 1, it says writing an inequality from a sentence. It says what inequality represents the sentence, the product of 7 and a number is no more than 50. So the product meaning multiplication. What are we multiplying? 7 and a number. They don't tell us what that number is though. So 7 is going to multiply with a number. Maybe we want to pick something like n to represent the number. Then it says is no more than. Is no more than is what we are looking at in terms of that inequality. So is no more than, well, what does that mean? If it's no more than, that means it's really not more than. And if you're not more than, well, what could you be? You could be a less than, or you can be an equal to. So if we have the product of 7 and a number, and we said we would use n, we can have 7n is less than or equal to, we'd have 50. It then says that the solutions of an inequality are the numbers that make it true. So for instance, if we had 7n was less than or equal to 50, any number I could plug in for n that would give me a number that's less than or exactly equal to 50 would be considered a solution. So for example, 5 would be a solution to that because 7 times 5 is 35, and that's less than 50. It says the properties you use for solving inequalities are similar to the properties you use for solving equations. However, when you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol. So I would put a little asterisk next to here. We need to make sure that we reverse the inequality symbol. So the properties that we have a transitive property. It says if A is greater than B and B is greater than C, then A is greater than C. So the example that they give us says that 5 is greater than 3 and 3 is greater than 1, so 5 is greater than 1. You do kind of some of this logic in geometry class. So if you've taken it, you may have already seen transitive. If you haven't taken that course yet, maybe you'll see it next year. The next properties are addition property. It says if A is greater than B, then A plus C is greater than B plus C. What you do to one side of the inequality sign, you do to the other, and it keeps the same inequality sign with addition. Same thing with subtraction. You can subtract the same value from each side of the equal sign, and the inequality sign is still the exact same. Now, multiplication and division is where we get into our little tricky spot with our inequalities. Remember that little sentence we put that asterisk next to? When you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol. So the first one says, if A is greater than B and C is greater than 0, C is greater than 0, that means you're dealing with a positive number, then AC is greater than BC. Nothing happened with the inequality sign. The next one says if A is greater than B and C is less than 0, C less than 0 means that is where we're dealing with that negative value. Look what happens. Our inequality sign goes from a greater than to a less than. So they said, for instance, if you look at the example, 3 was greater than 2, and it says -4 is less than 0. So if you were to take 3 times a -4, that would be less than 2 times -4, because you'd have a -12 is less than a -8. -12 would be less than a -8. The C value that they used, what they multiplied by, was a negative. So in order for that to still be a true statement, they had to make sure they flipped those inequality symbols. And then our division, it says if A is greater than B and C is greater than 0, again, that's positive, then you can divide both sides by C and get the exact same thing. Again, make sure that bottom denominator is not a 0, because you cannot divide by 0. But the bottom part says if A is greater than B and C is less than 0, so again, that means that that C value is a negative value, then you have to flip your inequality sign. So let's take a look at example 2. Solving and graphing an inequality. It says, what is the solution of 4 times the quantity x minus 7 is greater than -20? So our goal is to get x all by itself, and then they want us to graph the solution. So let's see. I see a distributive property, so we'll go ahead and we'll distribute. That's going to give us a 4x minus 28 is greater than -20. I need x all by itself, so just like we would do with our equations, we need to move that 28 first. That leaves us with 4x is greater than 8, and dividing by 4 leaves us with x is greater than 2. Now the number line I left blank with no numbers on it, so you can put your own. So typically I like to throw the number that I'm comparing right in the middle. So if I have a 2, I'm going to throw the 2 right in the middle. And I'm not going to use all these dashes. I'm going to skip 1 and call this 3, and skip 1 and then call this 4, and then going to the left 1 and going further left 0. So now when I go about graphing this, they tell us that x is greater than 2. That means I go to 2 and I always start with an open circle. Do I get to shade in that circle? Do I include 2 in this answer? I do not. It just says x is greater than. So that's my starting point, but I'm not including it. And then if x is greater than, the way that the inequality sign points would be a little hint to how you're shading, but only when the variable is on the left. If the variable is on the left, then the arrowhead points to the shaded region. We'll say it points to shading. So if x is on the left, and then I can just look at that little arrowhead, it's showing that I'm pointing off to the right-hand side, so I'm pointing to the right-hand side. X is greater than 2, so I want all the numbers that are greater than 2. And as I shade this in, I shade on top of the line, and I put a slightly larger arrowhead on the end. Example 3, it says using an inequality. It says a plumber A charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour, but no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? Let's see what we got. So we have plumber A to cost less than plumber B. So when I set up my inequality, I'm going to give myself a little hint. A is less than B. And if I go back and I take a look, it says plumber A charges $75 and adding $40 per hour. So I have plumber A is going to be 75 plus 40, and maybe we'll use H for hours. That is going to be less than plumber B. Well, what does plumber B do? Plumber B is just $50 per hour, so we just have a 50H. And they want us to know how many hours must a plumbing job last for plumber A to cost less than plumber B. That means I'm going to go about solving it. So I want to get the H's together. I find the smaller one, which is 40H, and I'm going to subtract that. Another hint in a problem like this, I would not want to move the 50H, because then I'd be left with 0 on that side of the equal sign. And that would not have helped me isolate my variable. So let's see, we'd have 75 is less than 10H. Get H all by itself by dividing by 10. That means 75 divided by 10 is 7.5 is less than H. What I like to do is I like to flip that whole thing around so I can read it as H compares to 7.5. The alligator mouth is going after the H, so the alligator mouth goes after the H. And then sometimes it doesn't hurt to just write out some words. So it wants to know, sorry about that, how many hours must a plumbing job last for plumber A to cost less than plumber B. So in order for it to cost less, 7.5 is exactly equal. You're going to pay the same to plumber A as you do to plumber B. So in this case, the hours is greater than or equal, or sorry, just greater than 7.5. So we can say at, well, we can't say at least because that would be an equals. So we're going to say it has to be greater than 7.5 hours. If I said at least, that would mean or equal to, and that's not equal. We're not looking for when they're equal. We're looking for when it's more. So it has to be greater than 7.5 hours. Example 4, the last one we're going to look at for today. It says, no solution in all real numbers as solutions. If you remember with solving equations, sometimes your variable disappears when you kind of start moving things around your equation, and you get a number compares to a number is equal to a number. Now with our inequalities, we're going to have some comparison. It says, is the inequality always, sometimes, or never true? If it is always true, that means it's obviously a true statement. If it's never true, that means it's obviously a false statement. If it's a sometimes, that would be that x compares with a number. Okay, so something to keep in mind. So part A, we have 3 on the outside of an x plus 3, so we'll go ahead and we'll distribute that out. And then we have a 3 on the outside of a 2 plus x, we'll distribute that out. So let's see, 3x plus 9. Greater than or equal to, we have 6 plus 3x. We want to get the x's together. Well, if I subtract 3x and I subtract 3x, this is where x's cancel out. And we're left with 9 is greater than or equal to 6. Is 9 greater than or equal to 6? Well, 9 is greater than 6. So this is going to be an always true statement. In part B, 9 minus x minus 5 is less than a negative x plus 4. Well, combine some like terms. We have a 9 and a minus 5. That leaves us with 4 minus x is less than negative x plus 4. We're going to add x. We're left with 4 is less than 4. Is 4 less than 4? If that was an or equal to, we may be okay because the or equal to, but 4 is not less than 4. This is going to be a never true because 4 cannot be less than itself.